Welcome to episode 6 of the devlog tutorial series. Today I'm going to demonstrate how I created a day and night cycle. I started with the simple sun and moon graphic. I dropped it into my project. Now to make it into something where the effect is visible, I'll need a quick playing field. Adding a tile map layer node and the tile map, and then quickly mocking up a simple playing field will work. Nothing fancy, just enough to see the effect of the lighting change. Next, I added a canvas layer to act as an overlay, and then added a Sprite 2D node and put my sun and moon image on there. A quick change to the size and position gets it in the upper corner, half off the viewing area as I want. I'll add a couple of point lights. The daylight really doesn't do much and could be left off, but the night light helps light up the moon a little bit, making it easier to see in the low light of night. Both the sunlight and the moonlight are colored and sized accordingly to sit on top of the sprite. As childs of the sprite, any changes in position or rotation to the sprite will automatically bring these lights along. After creating the daylight, I made the night light the same way. Next, I added a script to the sprite. I'll put my usual header for documentation purposes along with a couple of variables for the time of day and number of seconds, although this demo doesn't use the number of seconds, so you can leave it out if you're following along. A few constants for the length of the day and at what point the day and night cycle should start. For simplicity's sake, I stick with a 12-hour day and a 12-hour night. Down in the process section, I'll increment the time of day by delta in each pass, making sure that when the counter goes over the length of the day, that it is reset back to 0. In the code, I put in 359, but I should have used the constant value here. Finally, the owner of the script, the Sprite 2D, is rotated based on the incrementing time of day. A quick test, and it works. You can see the rotating sun and moon in the top corner. Using a fraction of delta allows for a much slower cycle. Next step is to make the lighting actually change. I'll add in a directional light and tweak the color. Changing into subtract mode and adjusting the energy allows for a convincing night look. It's just a matter of deciding how dark or light you want it to be at night. In code, I added in a reference to the directional light node and called it sunlight. Now I check the time of day and see if the start of day has been met yet, and if it is, not yet end of day. If so, I'll go ahead and decrease the impact of the energy setting. Remember, we have energy set to subtract, so the less we have influencing the scene, the brighter it will be. I will also check to see if it is past the start of night setting, and if so, start adding energy back in, which again in a subtract mode will result in a darkening of the scene. When I tested it, nothing happened, so something is wrong, but what? I realized that the rotation, while at work, was based on radians, yet our time of day, 360 values, is intended to match up to degrees. Simple fix. Adjust the rotation to change from degrees to radians. Now the rotation has greatly slowed down. To speed it back up for demo purposes, I'll multiply delta by 10. In an actual game, these settings would be tweaked until you get a cycle with the amount of real time your daytime and nighttime cycles should take to happen. When I test again, it brightens up as the sun rises, but fails to darken when the sun sets. One more bug to fix. Back in code, I see it as a simple typo, but I also see the potential for it to keep increasing, so I add in one more if statement to lock it into the expected ranges. One final test, and the sun rises as the scene brightens, and then as the sun sets, the scene darkens with the night. Also, you can see the effect of that point light on the moon when it darkens. Subtle, but there. The start of day and night are tweaked to better align the brightening and darkening with the rotation of the sun and moon sprite. Finally, how fast the lighting changes is a factor of the energy change constant. Make the constant larger or smaller to speed up or slow down the process. Removing the multiplication factor on delta also greatly slows down the day. If you found this useful, don't forget to like and subscribe and enable notifications for future videos.